Hello students, this is the first chapter of physics in your class 10 syllabus, light. So we have all studied about light before as well, but we know that light is not only a form of energy which helps us to see. In fact, light is also responsible for many more phenomena in nature. For example, do we know why sky appears blue? Do we know why during sunset and sunrise the sky appears reddish orange in color? Or what causes rainbow? So these are all the phenomena which are associated with lights and its properties. So we'll start with very basic thing, light, reflection and refraction. First of all, how can you see me? Or how can I see this remote or this marker in front of me? The basic phenomena associated here is reflection. So we are going to start with reflection. What is reflection? The light which is incident on this marker is getting reflected from the surface of marker and is incident on my eye. So unless and until the light from an object is coming to my eye, I won't be able to see it, right? So what exactly makes something visible in terms of color? For example, these are two balls, a red and a white ball. Why does this white ball appears white and the red appears red? The reason is red color, the ball red is in that color because you know that there are 7 different constituent of colors which is called Vibgyor pattern. Vibgyor is violet, indigo, blue, green, yellow, orange and red. So that red ball is reflecting only the red color and it is absorbing all the other colors, right? In fact, this white ball, this is reflecting all of the colors. So what will happen if this whole thing is illuminated by blue light? Remember, this is reflecting all the colors, whereas that is reflecting all the colors except red. Am I right? Actually, it is that thing is absorbing all the colors except red, right? Now it is a correct statement. So I am illuminating this whole thing by blue color. What do you think should happen? Will this appear blue or that appear blue? See, what actually is going to happen is that color, the red color now becomes black and white appears blue. So what exactly is the change? In this case, red was visible to us in red color because it was reflecting only red and it was absorbing all the other colors. So when it was illuminated by blue color, it absorbed blue and did not reflect it back, and that is why it was now appearing to be black. So a thing which absorbs most of the light and reflects very little will appear to us as black in color, whereas the white ball, this was reflecting all the colors. So even if one of the constituent color is incident on this ball, it will reflect that as well. That is why it started appearing blue. So this is a very basic phenomena associated with light, that is called reflection. So we have studied reflection from straight surfaces and we have studied a law which is from plane surfaces, a light which is incident at any angle will get reflected back on the same angle, right? Let's elaborate it more. This I equal to R, this was the basic law of reflection. What were the 3 laws of reflection which we have studied before? Laws of reflection. The first one was, and the most important was, angle of incidence is equal to angle of reflection. And second thing was that incident ray, normal and reflected ray, they all lie in same plane. They won't lie in different planes. So this thing can be observed even at your home by this simple experiment that you held a glass, a mirror, a plane mirror vertically using this clamp which you use for your paper clips, and you projected a laser at any particular angle. Here we have projected it angle 50 degree and it got reflected exactly from the 50 degree itself. So you see that angle of incidence is equal to angle of reflection. Now we have also seen that except I equal to R, there is one more thing, that reflection was divided into broadly 2 categories. One was regular reflection, one was diffuse reflection. Regular or specular reflection was what? When plane rays of light are incident on a plane surface, they will get reflected parallelly, right? Whereas in diffuse reflection, parallel rays are incident on an irregular surface and they will get reflected at different angles. That is what called as diffuse reflection. Now, next thing is reflection from spherical surfaces. Now, what do we mean by spherical surfaces? We already have an idea of convex and concave surfaces. So, spherical surfaces are surfaces which are made from purely spherical objects. consider a sphere. Okay, now this sphere is completely polished from inside, and this is mirror polished, or you can say silver polished from inside. Okay, so if this sphere is made up of glass, then from any part from the outside, because it is internally polished with silver, so from any point outside, if it is viewed, it will look like a glass, right? But definitely it won't behave like a plain glass, because this is spherical in nature. So now two parts are taken, one this much part and this curve part. That means this whole part is, let's say, destructed. So you are left with this surface and this surface. So these two surfaces are called spherical mirrors. What is this mirror? This type is called convex mirror. This type is called what? Is this a concave mirror? No, this is also a convex mirror. Why? Because in case of concave mirror, the polished surface is at the back side. So my point, why did I tell you in this way? Because I want you to know that a mirror is said to be convex or concave if it is convex or concave with respect to observer, right? So now this is a concave mirror. So this is how we make spherical mirrors. We take a sphere, there will be a center of sphere, right? If it is polished from inside, that will behave like, see, this is the polished part, the light gray and the dark gray is the glass part. So that is what we will call a mirror. So this one, if it is viewed from outside, this will be, because I am observer, I am standing in this side. So according to observer, this would be what? This would be a convex mirror, whereas that would be a concave mirror, right? Both of them are polished in the same direction. So concave mirrors are shaped like a part of the inside of the sphere, whereas convex mirrors are shaped like a part as the outside of the sphere, right? Next, this is how convex and concave mirror will behave if an object is in front of it. For example, that owl or the object standing on the principal axis, or doesn't, let's not discuss principal axis or focal length or whatever. Let's just simply see what is the difference in images. In case of concave mirror, you can see, you will find a small image, but that is inverted in shape. It is not important for us to know right now that the image is in that case is small and in this case is bigger. Important thing for us to know right now is, in that case, concave case, the image was inverted, whereas in this case image is erect. Number two, the image is formed on the same side of object. That means if I place some sort of screen there, the image will be formed on the screen, and that is why it would be called a real image. Whereas in that case, even if it is erect image, not inverted, the image is getting formed behind the mirror. That means even if I place a screen behind the mirror, I won't find anything on the screen. So this type of image is called virtual image. Okay, now this is how the mirrors in reality look like, and we are going to go and study about ray diagrams. So before we study ray diagrams, we have to understand some very important points of locations in a spherical mirror, which are, first of all, there will be your mirror either concave or convex mirror. This is a concave mirror, this is a convex mirror, right? First of all, this mirror is going to be, or it will definitely be, a part of a big sphere, right? So that means there would be definitely some radius or the center of the sphere. That C center would be called center of curvature. This is the first important point. Secondly, the centermost point on the mirror would be called pole. The line joining center of curvature and pole, the straight line, this would be called principal axis. Third point, lastly, half of the distance of this radius, because if this point is center of curvature, this distance would be the radius of curvature, because on this radius this whole spherical thing was made, and out of this whole spherical thing this mirror was carved out, right? So this radius of curvature, half of the radius of curvature is called focus. So this means this much distance would be called focal length. This is absolutely true in case of mirrors as well as in lens. Both the mirrors and both the lenses, that means convex and concave mirror both. In here, the only differences would be because when you look at the object or when you try to find an image, the object is placed always in front of the mirror. So even if it is placed in the front of convex mirror, those points which are center of curvature, focus, radius of curvature, they are all behind the mirror, whereas in case of concave mirror, they are all in front of the mirror. This is very important point when we'll apply the formula of ray diagram, that is how to find the position of image if you have the position of object. During that you need to do it according to sign conventions, and there these points come into very serious considerations. Now let's move further. As I told you, the important points to be remembered are optical axis or principal axis, center of curvature, which is the radius basically, or the centermost point of the spherical part from which the lens or the mirror was carved out. Half of the radius of curvature is called focus, all that distance is called focal length. This vertex is also known as pole. Now to make image or to make ray diagrams, you will have to learn about three very important rays, which are number one, the ray which will be